Hello and welcome to Math, Minecraft, and Computers, episode I19, BCD 7-segment display design. For this next part of the project, what we'd like to be able to do is take this 4-bit bus that we have here, bit 0, 1, 2, and 3, and put whatever we want on this bus, such as a 1, and have a big display here show in base 10 decimal whatever is on this bus encoded as a BCD number. So that would be 1, add a 4, this would be 5, and so forth. So the first thing we have to do is actually design the circuit before we can build it in Minecraft. So let's move over to something that will allow us to do that. Okay, so to design a circuit, what we can use is a truth table. And a truth table works like this. Over here on the left side, I have the inputs A, B, C, and D. Those are the inputs. And I have all the possibilities that we are interested in, which are 0 through 9, here in binary. So all of this records, this is bit 0, bit 1, bit 2, and bit 3 of our 4-bit segment from our BCD. Over here are then our outputs. These are the segments of the 7-segment display unit, segment A, B, C, D, E, F, and G. And so what we want to do is we want to go through all of these and say, okay, for instance, the output of 0, all zeros, which is A, B, C, D, all zeros, we want a 0 on the 7 segment. So a 0 is everything but the G. So I turn on all the segments and I leave G off, like this. And we want to continue doing that. We take number 1, for instance, 1, A is off, B is on, C is on, and everything else is off. And we just want to continue to do that. And so what we'll end up with is we'll actually have a table that looks like this when I'm done. Okay, so we have all of our outputs in place over here. We have our inputs in place over here. So this is saying for when A is not on, B is not on, C is not on, and D is not on, we want the A segment on, the B segment, the C, the D, the E, the F, and we want the G off. But what we really look at is this way, because we're going to say over here, we're going to have our segments. I'm going to use lowercase letters for these to handle the segments. So there's A, B, C, D, E, F, and G. A, B, C, D, E, F, and G. So those are our segments, and then we're going to start writing our truth table. So the way we do that is we have to look for our inputs. So for instance, I want to find a situation where only where it's a 1 over here. I don't care about the zeros. I want to be able to find out where to turn these on. Now these, I want to make sure I always, for this input, I have to have a 0. For this input, I have to have a 0 for this A segment. But all the others I want on. So I have to find some way to do this. Now one way I could do it, of course, is I could create a gate and say simply when not A, not B, not C, and not D. And I could continue to do that for all of these. So I would have 9 different cases over here. And then I would just simply OR those together at the end. And I've actually built that in Logisim so you can see what it looks like. And as you can see from this, it's pretty ugly because here's all my various 9 possible inputs, and here's all the segments that are here. There's a segment A through G down here, and they're all hooked up. So when I turn on whatever input I want here, I can get a number that will actually show. So for instance, there's 4, there's 5, I can turn this on and get 8. But that's a lot of wiring, a lot of work. And it can be a lot simpler than this. And that's what we want to do, is find a better way to do that. So coming back here, we want to look and we want to find situations where we can easily say, what can I do? For instance, here is the only 2 places where the A segment is on, and I also have both the A segment here and the A input is on at the same time. So that means if I just say when A is on, then segment A is on, then I've covered that. So I'll go through here and I'll choose a color for this and say that is going to be this. So I've taken care of those ones. Now what other ways can I do this? You might say, well, here's a 1, 0, 1, 0 in the BC segments, but if you look over here, I have a 0 and a 1. So that doesn't work. What about 0, 0, 0, 0? Okay, so far I can't do that either because I have a 1 and a 0 there. But I do have it down here. So if I have a 1 here, I have a 1 here, I have a 1 here, but because of that 0, I can't use BC. So I just have to find some sort of inputs that make sense, keeping in mind I've already covered these. Well, at least we do have if B is on here and D is on, I only have 2 of those. It's these 2 right here. So if B is on and D is on, and you'll see over here that in true, I do have 1s there. So anytime that B and D are on, I get a 1. So I can add that as a combo. If B and D are on, then I get a 1. So I'm going to find those situations. Here is B, there is D, so that one comes on, and it's this one here too. So I'm going to take those 2, and I am going to mark them with a different color so that we'll know where they came from. So I think in this case I will just use this color. And then we can also look at the same thing. I have the same thing going here when I don't have B and D on. I have a 1. If I follow that through, I don't have 1 there. And of course it's going to be this one here too, but we have a 1 there too, so it's fine. So what I want to do is anytime that I don't have B and D on, I get these 2 taken care of. So we're going to make that a yellow in this case, and then we're going to say not B, not D. Alright, now so as you can see what we have left is just this single bit is on. And if you look at here, I have C, 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 and all C's are on as well. So I can cover that last one, and actually these as well, by just saying if C is on here, then for the A segment, I also want it on. So those are the 4 pieces that you have. So if A is on, or B and D is on, or B and D are both off, or C is on, then I want the A segment turned on. So we're just going to change this to a color as well for our last one. That gets us the A gate. That is exactly the logic we need. So we're going to continue to do that through all of our different ones. And so we'll start with B. You can see that in the B segment, I have the same thing. I have these 2 on and these 2 are on. So using A is a possibility if I need it. But there might be other ways that I could do this too. And this is actually pretty unique because most of these you can see in B are actually on. And this corresponds with not B, not B, not B is actually these 4 here. And the other not B's. So in this case, by just saying if B is off, I want the B segment on. I get all of them but 2. So let me mark these like this. And I'm going to make those this color. So that is going to be not B. Okay, so when B is off, I want the B segment on. And actually you see I only have 2 left. I have this one and this one. Can I find a unique combination between those? It can't be B, because you'll see here when B is on, I've got a 0, so that doesn't work. I can't do B by itself. If I do 0, 0, 0, 0, 0, 0, you'll notice that all of those are on. So that is certainly one possibility I could do. If C and D are both off, then I will pick up, in that case, this one. So this will be a case where I have C and D. So it's not C and not D. All right, and then this last one you can see is exactly the opposite of that. It's the only place where I have both C and D on is here, here, and in both of those I have a 1 as well. So I can catch this last one with C and D like this, and that is now the B segment. I've got all the 1s taken care of in here. Now we're moving on to the C segment. The C segment, again, if these are on, these are on, so I have that in mind if I need to do that. But we've seen everything in this case, it's everything but this one. And that is the case where we actually have 2, where the C bit is on and everything else is off. So there's not a great way to catch this because I can't use this one. I can't use this one because that falls right in there. If I use the 1s here, that's a good one to use. As you can see, if I just say B in this case, I get all 4 of those. So I'm going to say B, just like that. That covers all of these and all of these, so I get these 4. So that's the B situation. So I've got 4 of those covered with one gate. And then you can also look and say, anytime that C is off here, like that, if not C, then I get this, this. Those are already covered, and this, this. So in this case now I need not C. So not C, here, 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 here. Those are all 1s. So I can do that as well. So it gets this one, this one, this one, this one. That is not C, and we're going to make it yellow. But then my last case that I have is this one here. And the question is, how do I catch that? Well, it's only case where C and D is on are these 2 right here. And in both of those I have a 1. So by doing a C and D, I can get that too. And you'll notice the interesting is I already have that gate used here. So it won't be a new gate. I already have it exactly right there. So we're going to take this last one and we will make it orange. So I've got the C segment gate taken care of. That moves on to D. Once again, these 2 are on. When these 2 are on, I can use that if I need to. We're going to look at several other combinations. And we know we've already looked at the not B, not D. There's only 2 of those. So it's a way we can catch a couple there. And we have this one here. And in all cases, you can see that not B, not D is on. So that is a good one that we're going to go with. So I'll do not B and not D. And that gets us this one. Here this one. And then of course this one down here. So that is not B, not D. And then we have several others we can catch. We've got to find some combination between these remaining that mix. So we have a 1 here, we have a 1 there, but we have a 1 there where it's off, so we can't rely strictly on that. What about 1, 1? You see 1, 1 is the 0, so 1, 1 doesn't work for the C and D in this case. But if we keep looking, we will find, at least in this case, you see that when C is on and D is off, we have it here, we have it here, that's that one and this one, and that's the only place where we have C, not D. So that covers 1 that we've already done, so that's going to be C, not D. Like so. And then to get this last one here, we have B is one of the ones we can use, but here's a B where it's off, so we'll have to combine that. But the difference between this one, this is off, and this is on. So is it possible for me to use B and C? So it would be basically not B, not C. That's this one here. Not B and C is on, gets this bit. But you notice right, here's one too. So these are this is the not B, and C is on, and I have no others like that. So I can use that as well. I can say not B and C, and that will take care of this one right here. Now, I have at least one more that I still have to deal with. I still, first of all, have this one down here. And the easiest way to take care of that is just go ahead and add my A gate into there. And that will be that one. So it's really these 2. So I think I'm going to use that same color for those 2 just to make it simple. And then the last one I have is I have to have this one. I have to find some way to differentiate. And this is a case where I have B. This bit doesn't matter because there's too many zeros. And I'm just going to take all 3 of these to be able to get this last one on, because there's no combination. Those 2 are different. There's the 0, 1, but there's a 0, 0. There's a 1, 1, but there's a 0, 1. So I'm going to have to use all 3 to do that. And then it's going to be B, not C, D. You see that right here. B is on, not C and D, and that will get this last bit right here. Okay, moving on to the E gate. E, you can see, only has 4 on, so this one should be pretty easy. Right off the bat, I say, you can see this right here. that's these. So that gate, which is not B, not D, which we already have right here, and here is available. So not B, not D. That will get this one and this one here. And we will turn those blue. So we've got those two taken care of already. Not B, not D. And then the last one, of course, these two right here, we have C, not D, and then another C, not D is right here, and if you look, those completely correspond with what we have. We have no other. So in this case, it's really simple. We only need two gates. A C, not D goes there, and not B, not D. Moving on to the F gate. We already have these two down here, so I'm just going to go ahead and add the A right away. That's going to get these two. And then we have to handle all these other situations too. Well, we already can look at our gates. We have a couple that we can use. We've been successful. What about not B, not D? That doesn't work because we have a 0 in this position right here. So not B, not D isn't going to do it. What about not C, not D? We don't have very many of those. They're all right here. And you can see they are on. So we can get two that way. So that's going to be not C, not D. And that takes care of this one, not C, not D. That one, not C, not D. And this one, which already is taken care of by our previous gate. So I'm going to do that. Now we also have several other gates that we have options for here as well. We can check out our B, not C situation, which is this one, B and not C, B and not C. And we actually have that one taken care of. Those are the only B's and not C, so it easily gets that gate. I can't get this one at the same time because between these two gates, these three bits are all different, so I have no combination that I can do. It actually looks like it's best to, in this case, go ahead and find a way using B and D. So in this case, I have, for this bit right here, I have B and not C. And the other B and not C that you see is this one right here. And I have a 1 for both of those. So this one is B, not C. So B, not C. And then that leaves this last remaining bit, which if we want to stick with the B bit, then we know that it's B and not D in this case. So there's B and not D, which we have here. And those are both 1s, so that takes it as well. So B and not D. That gets this last bit right here. And we're done with the F gate. Now the G gate. The G gate only has 3 cases where it's off. It would be nice to be able to say we can use these, but as you see we can't. Can we use all the 1s? And once again you see that we can't. So not as easy as we thought, but we still have our situation down here where we can just say if the A gate is on, then we want this on. So we put that here. Now we can start looking at some of the gates we already have. I want to fix this. So now that I fixed those, we have a couple of choices. For instance, the not B, not C is a gate that we've already used, and it's a good one for here because not B and C is here. Those are the only 2 gates where you have not B and C, and we both have a 1 there. So in this case, we are going to put not B and C, and that is going to get these 2 right here. So it's this one and this one, not B and C. And then we can do the opposite of that to get these 2, just like we did last time. So that's going to be B and not C. Any situation where you have B and not C, remember it's only those 2 where we have that, so that will get these 2. So that is B and not C. And then this last one, to get it, pretty simple. We can do C and not D, because we have that here. There's only 2 places where we have that. That is a 1 up there. So that gets that too. That last one is C and not D. and that gets this last piece. So now we actually have the map that we need for our table. So for A, we build and turn these gates and connect that to the A segment. We build these gates, connect it to C. So what we will do next time is we'll actually do the Logisim work to create this and do our prototype in Logisim so we can then build it in Minecraft to do a BCD binary display. That is it for I19 BCD 7-segment design. Hope you enjoyed. Give me a thumbs up if you like, subscribe for more if you would like to continue, and that takes care of this. Roy out.